Hey guys, welcome to Learn Today IGCSE. This is a tutorial video for Physics Paper 6 Alternative to Practical, Variant 6.3 for May June 2023 examination. Question 1. A student determines the mass mR of a meter ruler by a balancing method. He uses the apparatus shown in figure 1.1. As you can see here, we've got a meter ruler, meaning that it is 100 centimeter in length. You've got a pivot point here, the 50 centimeter mark in the middle, and the load being placed at a 5 cm mark. All of these are held on a bench. Question A. The student places a circular load of mass m equals to 20 gram on the meter ruler, but in a position different from that shown in figure 1.1. Determine the distance d0 of the center of the load from the zero end of the ruler as shown in figure 1.2. Figure 1.2 is not to scale. So we know that this is the zero end of the ruler and the center of load would be at the midpoint of 6 cm and 9 cm. So this means that our center point is at 7.5 cm. That would be the distance of d0. And your units are already given, so you can just leave your answer like this. Question B, Part 1. The student places the meter ruler on the pivot and changes the position of the load so that the center of the load is at the 5 cm mark. He adjusts the position of the meter ruler on the pivot until the meter ruler is as near as possible to being balanced. Describe a technique for ensuring that the ruler is as near as possible to being balanced. A method to find the point at which the meter ruler is as near to being balanced as possible is move the ruler to find the point at which the ruler just tips one way. Part 2. The student determines the scale reading P on the ruler at the position of the pivot. He calculates the distance A between the 5 cm mark and the pivot and the distance B between the 50 cm mark and the pivot using the equations. He repeats the procedure for values of m equals to 40 gram, 60 gram, 80 and 100. His results are shown in table 1.1. For the value m equals to 20 grams, calculate and record in table 1.1 the value of b over 1. This should be pretty simple as the value of b is 5.5 over a, which is 39.5, would give us a value of 0.1392. Since the other values are written in two significant figures, we will also write our answer as two significant figures. Question C. Plot a graph of m, g, y-axis against b over a, x-axis. Refer to your table and plot your points accordingly. This is what a best fit line will look like. I have already explained in detail how to draw a best fit line and how to plot your graph step by step in Paper 6-2 May June. You can click the link above to learn how to plot a best fit line and how to choose an appropriate scale for your graph. As for this graph, these are the outlines that you can look up for to see whether or not you are able to get a complete 4 marks. Question D, Part 1. Determine the gradient g of the graph. Show clearly on the graph how you obtained the necessary information. Use the triangle method to calculate the gradient. Choose 2 points on the line of best fit. Track the points to each axis by drawing a line with a pencil and ruler. Determine the values of each point on the x and y axis. Now we can use the gradient equation to calculate the gradient. According to my graph, I obtained the value of g equals to 150. You must show the triangle method in your graph in order to obtain 1 mark. The mass mR of the meter ruler is numerically equal to g. Write down the value of mR in this experiment, include the unit. So you can write down any value that you obtain in g in the answer section for mR. According to your marking schemes, any value within the range of 140 to 170 is an acceptable answer, and the unit for mass would be g. Question E, Part 1. The determination of mR by this method assumes that the center of mass of the meter ruler is at the 50 cm mark. suggests how you could use apparatus from figure 1.1 to test whether the center of mass of the meter ruler is at the 50 cm mark. You may draw a diagram. To test whether the center of mass of the meter ruler is at the 50 cm mark, you may place the meter ruler on pivot without mass M and read the position of pivot when ruler is as near to balance as possible. Part 2. A student finds that the center of mass of a meter ruler is at the 48.7 cm mark. Suggests how she changes the procedure in B Part 2 to allow for this. Okay, this would be quite simple. This is B Part 2. And since the student observed 48.7 instead of 50 cm, we will replace the equation B 48.7 minus P instead of 50 minus P. Question 2. A student investigates a circuit containing different combinations of resistors. She uses circuit A shown in figure 2.1. Circuit A is not yet complete. As you can see here, the switch is not closed. We have a power supply, an emitter connected in series to read the current, and two resistors placed in series. Question A. On figure 2.1, complete the circuit to show a voltmeter connected to measure the potential difference PD across resistor U. The voltmeter is always placed in parallel across the component that you are measuring, and in this case would be resistor U. Question B, Circuit A. The student measures the potential difference PdV across resistor U and the current in the circuit. Read and record in Table 2.1 the values of V and I shown on the meters in Figure 2.2 and Figure 2.3. As we can see here, V shows 1.7 volts and the ammeter displays a reading of 0.42 amperes. So we are going to use these values and fill in the table. According to Ohm's law, we know that V equals to I times R, meaning that R is V over I. So using this formula, we will be able to find the resistance of circuit A, B, and C. You can leave your answers in 3 significant figures or 2 significant figures, as long as when you choose one and you stick with it. Question C. Circuit B has 2 resistors connected in parallel to each other. And for circuit C, you have 3 resistors connected to parallel to each other. The student connects 2 3 ohm resistors in parallel between P and Q as shown in figure 2.4 to form circuit B. The student connects 3 ohms resistors in parallel as shown in figure 2.5 to form circuit C. For each circuit, she measures the potential difference V across resistor U and the current in the circuit. Her readings are shown in Table 2.1. Part 1. Calculate and record in Table 2.1 the resistance R of resistor U for each combination of resistors. Use the readings from Table 2.1 and the equation R equals to V over I. Alright, so looks like we've already completed this part. Moving on to question part 2. A student suggests that the values of R should be the same. State whether your results support this suggestion. Justify your statement by reference to values from your results. As you can see here, the values of R are not too far apart from each other. The average roughly looks like 3.9. So this means that the student's suggestion that R should be the same is correct. And for justification, you could say that the values are within limits of experimental accuracy. Question D. A student determines the resistance of resistor U using a variable resistor to control the current in the circuit. Part 1. Complete the circuit in figure 2.6 to show a variable resistor used for this purpose. The variable resistor is placed in series and the rest of the circuit, which is a small part of wire, is drawn. The variable resistor can be placed at any point in the circuit because the current is the same everywhere in a series circuit. Part 2. Briefly explain one advantage of using a variable resistor to determine the resistance of a resistor U rather than the procedure carried out in Part B and Part C. The procedure carried out in Part B and Part C was by investigating a circuit by using different combinations of resistors. And right now, they're using just a variable resistor instead of combinations of different resistors. This can make your experiment easier to perform because It is now more straightforward or easier to change and control the current. Or you could also say any of these two. Question E. A student suggests that the potential difference and current for resistor U are proportional. Suggest how a graph of potential difference against current for resistor U can confirm this suggestion. So, according to Ohm's law, this is what a graph of potential difference against current for a resistor looks like. And the student suggests that it is proportional, and as you can see in the graph, there is a straight continuous line from the origin until the end. So this confirms the student's suggestion. If you have a different answer, you can just leave it in the comment section and I can help check it for you. Question 3. A student investigates the reflection of light by two plane mirrors. The student's ray trace sheet is shown full size in figure 3.1. Okay, let's take a minute to just understand the setup of this experiment. Okay, so technically this is what the setup of the experiment looks like. These are the mirrors that are being placed at 100 degrees against each other, and the first pin 1 and pin 2 are set up at an angle as theta. So what happens is that you will be able to see all the pins being reflected on this side of the mirror. Okay, I hope this is not too small for you. I'm just gonna place the question by the side of the ray trace sheet so that it will be easy for us to answer. Question A. The student places two mirrors FE and FG at an angle of 100 degrees to each other, as shown in figure 3.1. Part 1. On figure 3.1, draw a normal to FG at point N. Extend the normal below FG. Label the lower end of the normal with the letter L. So this will be the upper end and this is the lower end. Remember that normals are perpendicular or 90 degrees towards the boundary. Part 2. The student draws line AN as shown in figure 3.1. On figure 3.1, measure the acute angle θ1 between the lines AN and GN. Okay, when you're looking for an angle, make sure to always use a protractor. So this is the angle θ1 that you're looking for. According to my scales, I got a value of 15 degrees. According to your marking schemes, any value between 14 to 16 is acceptable. And as you can see here, they have already given you the unit degree. Question B. The student places two pins, pin 1 and pin 2, on line AN, as shown in figure 3.1. Measure the distance D between the pins P1 and P2. Since I'm solving this on an iPad, this diagram is not up to scale for me, but in exams, using your ruler, measure the distance between P1 and P2 like this, and you will get a value of D equals to 3.5 cm. Part 2. Suggest whether the two pins are a suitable distance apart for accurate ray tracing. Explain your answer. The distance apart for P1 and P2 is only 3.5 centimeters. When performing a ray trace experiment, you should place your pins at least 5 cm apart from each other. So the two pins are not at a suitable distance, and the explanation is that it should be as far apart as possible. Question C. The student views the images of P1 and P2 in mirror FE. She places two pins P3 and P4 so that pins P3 and P4 and the images of P1 and P2 all appear one behind the other. The first bullet point, draw a line through P3 and P4. Extend the line 10 centimeters above FE. Again, I'm not drawing this using a scale, so my drawing and the results might be a little bit off in the end. Okay, so now I'll draw a line through P3 and P4 and extend the line 10 centimeters above FE like this. Bullet point 2. Label the upper end of this line with the letter R. Bullet point 3. Label the lower end of this line with the letter B. Alright, done. Question D. The student repeats the procedure for an angle theta equals to 40 degrees. She places two pins P5 and P6 so that pins P5 and P6 and the images of P1 and P2 all appear behind the other. Bullet point 1. Draw a line through pins P5 and P6. Extend the line until it crosses BR. Bullet point 2. Label the upper end of this line with the letter T. And third bullet point, label the lower end of this line with the letter C. Next, part 1. Measure the acute angle alpha between the lines BR and CT. Okay, just place your protector accordingly and you should get an angle for alpha within the range of 25 to 29 degree. Part 2. A student thinks that there is a relationship between angle alpha and the angle theta 1 from A2 and angle theta 2 from D. State whether your results suggest that the relationship could be. Justify your answer by reference to values from your results. So the angle of theta 1 is 15 degrees and the angle of theta 2 is 40 degrees. This gives us a difference of 25 degrees, which is roughly the angle of alpha here. So since the value of alpha is the difference of angle theta 1 and angle theta 2, we can say that yes, there is a relationship between them. And for the justification, you could mention that this is because the statement matches the values. Question E suggests 2 precautions to take in this type of experiment to ensure accurate results. So I have gone through this in video paper 6 variant 6.1 and 6.2. If you want more detailed explanation, please watch and refer to that video. Question F suggests one reason why different students, all doing this experiment carefully, may not obtain identical results. It is difficult to align the pins along the reflected ray, so this may result in different students obtaining different results. Question 4. A student investigates the rate of cooling of hot water in a container which has a lid. Plan an experiment which will enable him to compare the effect of lids with different thickness on the rate of cooling. Before planning, let's identify the key variables. So I like to use the initial words IDC, I don't care, to remember which variable I am looking for. Now the independent variable is what being changed in this experiment. And as you can see here, we are comparing the effect of lids with different thicknesses. And for dependent variable is the variable you're looking to measure or record, which is the rate of cooling. And for the control variable, you need to identify what other parameters for this experiment should be kept the same so that the experiment is fair. Since we are cooling a hot water, I think we should use the same amount of volume for water. Okay, now that we have identified the variable, let's continue. The apparatus available includes a beaker, a supply of hot water, insulating material from which lids can be cut. Now, to plan your experiment, you should include all these bullet points. And we have 5 of them here. You may also draw a diagram if it helps to explain your plan. So now we are going to plan the experiment according to each bullet point step by step. For the first one, list any additional apparatus needed. Since we are looking for a rate of cooling, we need to measure the temperature. To measure temperature, we're gonna need a thermometer. And rate means speed of time. This means we also need an apparatus to measure time, in which we could use a stopwatch. When asked to list additional apparatus, make sure to mention at least 2 to get a complete 1 mark. Bullet point 2. Explain briefly how to do the experiment, including the measurements to take so that the rate of cooling can be determined. When you are asked to explain briefly how to do the experiment, please remember this. I have came up with a method called Monkey Really Rocks, MRR, which stands for Measure, Record, and Repeat. So when you are asked to explain how to do the experiment, make sure you include these 3 keywords. You are always going to measure your independent variable, which in this case is the lid of different thickness. Next, you're going to have to record your dependent variable, which in this experiment is your rate of cooling, which means you have to measure the time and the temperature. And lastly, do not forget to mention repeat. And what you're repeating in the experiment is always your independent variable, which is the lids of different thickness, so you can mention that repeat for at least 4 other thickness of lid. Okay, you're done for the second bullet point. Now bullet point 3. State the key variables to keep constant. When you are asked to state the key variables, please mention at least 2 key variables to keep constant. We already have the first one here, which is the volume of water. And for the second key variable to keep constant, you should ensure that the initial temperature of the hot water is always the same. If you have any other answers, just leave it in the comment sections below and I will check it for you. Alright, done. Moving on to the 4th bullet point. Draw a table or tables with column headings to show how to display the readings you are not required to enter any readings in the table. So when drawing table, you need to have a column for your independent variable, including your unit, and your dependent variable, also including your units. If you do not display your unit, you will not get a mark for this bullet point. And you're not required to enter any values or readings in your table. Okay, done. And moving on to your last bullet point, explain how to use the readings to reach a conclusion. This is a very common point that they will ask you when planning your experiment. And the answer is always the same: plot a graph. But you need to specify the axis for the graph. In this case would be the rate of temperature change against the thickness of lid. Make sure you specify your axis, otherwise you will not obtain a mark. Okay, now we can write down all our answers here in the answer space provided. When you guys write your answer, please make sure that it is in a paragraph form and do not write like this. This is just a way of me writing so that you guys can see how the marks are being given. So for bullet point 1, you have mentioned at least 2 apparatus, you will get 1 mark here. For explaining the experiment, you have used monkey relay rocks, MRR, measure, record, and repeat. You will get 2 marks here. The variables to keep constant, you have mentioned 2, so you will get 2 marks here. For bullet point 4, drawing your table, you will get 1 mark only if your units are also included. And finally, on how to display your graph, bullet point 5, after mentioning and specifying your axis accordingly, only then you will achieve 1 mark. So that's how you obtain a complete 7 marks. If you want to be safe and feel like you might forget 1 or 2 points, you can always write, repeat the experiment for each thickness several times and get the average reading. Okay, that's all for this paper. Thank you so much for watching until the end of the video. I hope it was worth your time. If you liked the video, please don't forget to like, comment, and subscribe to my channel. Bye!